Hello, and welcome to Grade 9 Science, Unit B, Section 2 review of the periodic table. I make these PowerPoints solely to help my students, but if there's anyone else that this can help, that would be good as well. This is the beginning of 3 parts that reviews the periodic table. So here's the outline of some of the key concepts we're going to talk about and some of the questions that you will be able to answer after you go through these PowerPoint slides, this presentation. So one of the things that we have to understand is we have to understand how we make sense of the world, and specifically how scientists do it. So the first thing to do is to ask a question. Once you ask that question, you can come up with a test to try and answer the question. Once you have a test, or in other words, once you have an experiment, do the test, do the experiment. And while you're doing the test, things will be happening. So after you do the test, you make observations. In other words, what are the things that you witness during the test? What are things that you hear? What are things that you see? What are things that you even smell, etc.? You use these observations to make theories to help predict what would happen in similar situations. Theories should be able to predict what might happen and explain what happened in your experiment. So we're going to start talking about the periodic table, but it does well for someone to understand where the periodic table comes from. And this is very important because we start to understand the difference between scientific work and non-scientific work. So this title says it all right here. Theories about matter change over time, and that's the nature of science. So we start off with the Stone Age, then we go to the Bronze Age, Iron Age, and then we're going to go into the time of the philosophers and talk a little bit about alchemy and experimentation from the 1500s and on, and then the onset of the atomic theory, which leads us in to discussing the periodic table. So we're going to start with the Stone Age. The Stone Age receives its name from the fact that most human tools preserved from that time are made of stone. Metal had yet to be discovered. Humans made simple stone and bone tools. Life improved when humans discovered how to start and control fire. So this is one of the very first chemical reactions. They used fires for staying warm and for cooking food, which assisted with digestion. Humans ate animal organs, including liver, kidneys, and brains even. They consumed very little dairy products. They also consumed vegetables and cereal grains. Artistic designs of animals and humans were painted on rocks. Animals represented strength and human courage. Ritual dances were done as well, and they're commonly associated with the Stone Age. So those are some things. So the main thing to know is fire was used to make tools and to cook and to keep warm, and humans used very rudimentary simple tools. So now we go to the Bronze Age, which was from 6000 to 10,000 BC. Chemists investigated properties of matter that were of interest to them, like gold and copper. Gold was used to make jewelry due to its color and shine, and it didn't tarnish. It was used for currency and for coins as well. Copper was used to make pots, tools, coins, jewelry, and later, after discovering its properties when heated, to create a metal called bronze. Bronze, all that is just tin and copper heated, and they meld together. From the creation and use of bronze, scientists began to look and research other materials. So this led to further investigation of other things. So gold has a nice color, has a nice shine to it, and it doesn't really lose its shine. It's part of its physical properties. Copper is used to make pots, coins, and it's brittle. but when it's heated it gets quite strong. So the Iron Age, around 1200 BC. So iron was combined with carbon to make steel. And I guess I cut off some of the notes there. I'll have to go back and fix it. But you have a group of people called the Hittites, and they discovered how to extract iron from stones, and that's starting the Iron Age. Eventually, iron was combined with carbon to make steel. Steel was a much harder metal, and uses for this metal were widespread. Swords, blades, etc. were uses. And people started actually extracting liquids and oils from different plants. Typical uses were preservations, and like the Egyptians would wrap their dead in fibers soaked in these oils and juices that would help preserve the corpse, and that's the mummification. So as I said earlier, there's the Hittites, and they were responsible for making steel in the Iron Age. So now we go towards the philosophers. Not everyone used science to try to understand matter. Philosophers were thinkers, and that's important to understand that the ideas of philosophers did not come from scientific observations. Philosophers are people typically thought very deeply about the human experience, and especially the connection that people have with the world around them, which is, partly, the scientific interest as well, but philosophers take things from a different angle. So the Greek philosophers were interested about matter and what makes up matter. So how could you find out? And that was the question they tried to answer. What are things made of? And the thinkers, the philosophers, they just tried to explain matter based on simple assumptions that the ordinary people could understand. They're not based on scientific observations, as I said. Okay, that's important to understand. So the first Greek philosopher, about 4000 BC, his name was Democritus, and he's pretty significant because he started to explain about the idea that things are made up of tinier things, and he called those things atomos. And atomos is Greek for indivisible. So he explained that all materials had different atomos, which gave the substance its characteristic properties, which is, kind of a pretty interesting idea. Another philosopher, Aristotle, thought otherwise. His idea was that everything was made up of the four main elements, and we'll talk about that in a little bit. So this next slide here I have Democritus, and again, so he really started talking about the smallest particle as atomos, and if you look at the word atomos, it should remind you of the word atom. So Aristotle kind of disagreed with atomos, and his idea was that everything was made up of four main elements. And here's all of these images I'm taking from online sources. I have credit for them here, but this is some really good advice that I just kind of threw in there, and you can read it at your own leisure. So the four elements that Aristotle thought made up everything else was air, fire, water, and earth. And a little typo there, but the idea these ideas were accepted for over 2,000. Next is alchemy in around 1500. Deserves a little bit of attention. So it was practiced openly in the 1500s and the 1600s. And the alchemists were a group of people that were considered to be part scientists and part magicians. They had two purposes. Their first purpose was to take any metal and make it into something valuable. So they want to take any kind of metal and turn it into gold. That's what they wanted to do. And the second thing they wanted to obtain is they wanted to create a magical kind of an elixir. So they were interested in preserving life and curing disease and all that sort of stuff. And they wanted to create an elixir that would preserve life. And they call this elixir the Philosopher's Stone. Now, alchemists are not considered to be scientists. And these initial experiments can sound a little funny, but in this process of trying to create gold and coming up with the Philosopher's Stone, they made some important contributions to modern day chemistry. And so, for example, plaster used to for all sorts of reasons was discovered by alchemists. They also developed a lot of the instruments that modern day chemists use today. Alchemy is called a pseudoscience. This is actually important to understand. And the word pseudo means sort of. So the process through which the alchemists initiated performed their experiments was not strictly scientific. It was sort of scientific. Alchemy is not considered to be a scientist. We've now reached the end of part 1, and I hope that this was helpful, and hopefully you'll check out the next video.